Welcome to the Explainer. Today, we're going to break down one of the most, transformative technologies of our time, generative AI. We're going to look at what it can do, how it works, and really get into that critical balance between its incredible promise and, its undeniable peril. All right, let's jump in. So let's just start with a simple question. What if a machine could create, pretty much anything you could imagine? I'm not talking about just calculating or analyzing data, but truly creating brand new, original stuff. That's really the core idea behind generative AI.
I mean, just think about it. It could write a poem that doesn't just string words together, but actually captures a certain style, maybe even a feeling.
Or it could create a totally photorealistic image of a place or a person that has never, ever existed. It could compose a piece of music. I mean, you name the genre, it can probably do it. And get this, it can even write the code that builds our entire digital world. And the crazy part, this isn't some far-off science fiction fantasy. It's happening right now. So, what is generative AI? How does all of this work? It's time to pull back the curtain and take a peek at the magic happening behind the scenes. Okay, so at its core, generative AI is all about models that learn from just enormous amounts of data. I'm talking about basically the entire internet, books, images, code, you name it. And then here's the key part. They use those learned patterns to generate totally new stuff. It's really not just copying and pasting. It's more like it's learned the rules of what makes a cat picture look like a cat picture, and then it can create a brand new cat that's never existed. This quote from IBM really nails it. LLMs work as giant statistical prediction machines that repeatedly predict the next word in a sequence. You know, it sounds almost too simple for something so powerful, right? But that's basically it. For text, these models have read so much stuff that they've gotten incredibly good at guessing what word should come next. So when it writes a sentence, it's just playing a super advanced game of what's the most likely next word over and over again. And the engine that powers all this text magic, that's what we call a large language model, or LLM for short. And you gotta emphasize the large part. These things are trained on data sets so huge, it's honestly hard to wrap your head around, like a massive slice of the entire internet. That's exactly why tools you've probably used, like ChatGPT, can talk so convincingly about, almost anything. So what was the big breakthrough that made all this possible? It's something called the transformer architecture, and it came from this groundbreaking paper in 2017 with a great title, Attention is All You Need. Before this, AI models read text kind of like we do, one word at a time. The problem is that makes it really hard to understand context. But the transformer, with its special attention mechanism, can look at a whole sentence or even a whole document all at once. It sees how every single word relates to every other word. So, for example, in the sentence, the robot picked up the ball because it was heavy, the model knows it refers to the ball, not the robot. That little trick changed everything. And that breakthrough just kicked off this incredible race, this explosion of innovation. So let's take a quick look at the history of GPT and see how this stuff went from a lab experiment to something on millions of our laptops. I mean, the growth here has been absolutely exponential. Just look at this. In 2018, we get GPT-1. Fast forward just 2 years to 2020, and GPT-3 comes out with 175 billion parameters. You can think of parameters as kind of like knobs the AI can turn to refine its answers. More knobs means a more nuanced, smarter model. But the real earthquake was in 2022, right? When ChatGPT was released, and suddenly everyone, and I mean everyone, had access to this power. And then, a year later, GPT-4 goes multimodal, meaning it can understand images, not just text. It's just incredibly fast. So all this rapid-fire evolution has just unlocked a whole new era of what's possible. Let's talk about AI in the real world. What does this power actually look like when you put it to work? This is the promise of a new era. And the impact is already staggering. We're not talking about minor improvements here. We're talking about accelerating drug discovery by analyzing incredibly complex biological data. We're talking about a company like UPS using it to optimize its unbelievably complicated global supply chains. Even in cars, Mercedes-Benz is using it to create in-vehicle assistants that you can actually talk to like a person. From banking to video games, I mean, it's touching just about every industry you can think of. Okay, But with all of this incredible promise comes some really significant peril. For every one of those amazing applications, there is a flip side, a risk that we absolutely have to talk about and address. And these risks are no joke. The National Institute of Standards and Technology, that's NIST, they've actually created an entire framework just for managing AI risks. And one of their most sobering findings, the potential for this tech to help bad actors get their hands on information about chemical, biological, radiological, and even nuclear weapons. It's a really serious concern.
And beyond that really extreme threat, there's a whole bunch of other critical risks we need to manage. You have confabulation. You've probably heard it called hallucination, where the AI just makes stuff up that sounds completely plausible but is totally wrong. Then there's harmful bias. Since the AI learns from us, it can pick up and even amplify our worst societal biases. Of course, there's the whole issue of deepfakes and misinformation, which is a huge threat to just knowing what's real anymore. And that's not even getting into the massive questions around data privacy, who owns what when an AI creates something, and the enormous amount of energy it takes to train these things. So, with all those challenges, what's the path forward? How do we build trustworthy AI? The goal here isn't to just slam the brakes on all this innovation, it's about steering it, right? Building the guardrails we need to make sure this is all done responsibly.
Yeah, it's really not about stopping innovation. It's about guiding it. And there's a real consensus growing that we have to guide it responsibly with clear frameworks and guardrails. This isn't something you can just fix with more code. It's a human problem that needs good governance and a real commitment to making sure these things align with our values.
And this isn't just talk either. People are already building these frameworks. This table, for instance, is from that same NIST report, and it lays out some really concrete actions. Things like, figuring out who owns what, making sure there are clear contracts in place, and keeping good records so you can track changes. This stuff is the practical, nuts and bolts work of building trustworthy AI. It's a real roadmap. Now, on the technical side of things, it kind of boils down to three big ideas. First is human feedback. This is a huge one. It's where humans are literally in the loop, teaching the AI and rewarding it for being helpful and safe. Second is something called data provenance. This is all about being able to trace where AI content came from, using things like digital watermarking. And third, and this might be the most important, is just a serious commitment to transparency. That means being open about what data the AI was trained on and what it can and can't do. When you really get down to it, generative AI is like a giant mirror. It's trained on the sum total of our knowledge, our culture, our creativity, but also our flaws and our biases. It doesn't really create anything from a vacuum. It just reflects back what we've already put out into the world. So as we build this thing, the real question isn't just about programming a machine. It's about deciding what parts of ourselves we want it to amplify. So the final question for all of us is this: what do we want that mirror to show us?